times independent variable, isn't it? Then in case of second, sine or cos, what we are doing? We are replacing d square by a square, d square by minus a square. We have seen the logic behind that replacement, right? So to get the particular integral in case of sine or cos, normal sine or normal cos, we are replacing d square by minus a square. And in case of hyperbolic function, we are replacing d square by plus a square. So let me start with that. Case 3, that is when fx is sine hyperbolic ax plus b or hyperbolic cos ax plus b. I hope the screen is visible, right? So pi particular integral is 1 upon phi of d f of x. So first of all, we write this phi of d in terms of d square. So phi of d square, if d square is not there, then how do we get d square? By rationalizing the denominator. And suppose if we take the sine function, hyperbolic sine function, so a hyperbolic sine of ax plus b, isn't it? So here the case says we just replace this d square by plus a square. 1 upon phi at a square hyperbolic sine ax plus b. Okay. So this is the logic behind this particular integral. But now sometimes some examples can be solved using the exponential forms of these hyperbolic functions also. If it is difficult and lengthy, by the substitution, like by replacement d square by a plus a square, what we can do, we can write this hyperbolic sine function in terms of exponential. How do we write? Do you know the formula of hyperbolic sine theta in terms of exponential? Hyperbolic sine theta क्या होता है in terms of exponential? It is e to the power I theta minus e to the power minus I theta. It is not I theta. E to the power theta minus e to the power minus theta upon 2. And similarly, hyperbolic cos can be written in terms of exponential, that is e raised to theta plus e to the power minus theta upon 2. Yes or no? So these are the hyperbolic functions in terms of exponential function. So therefore, I can write this hyperbolic sine ax plus b as a e to the power ax plus b, or simply ax, minus e to the power minus ax upon 2. And hyperbolic cos can be written as e to the power ax plus e to the power minus ax upon 2. Okay? So either we can replace d square by plus a square, or by getting the exponential forms of this sine or cos, we can proceed further with the first case, right? Exponential case. Okay? So this is what the hyperbolic function case. Then the next is case number 4. If fx is a polynomial function, पॉलिनोमियल फंक्शन कैसे होते हैं? लाइक एक्स स्क्वायर और एक्स क्यूब और 1 प्लस एक्स स्क्वायर और 2 प्लस एक्स क्यूब, लाइक दिस, है ना? So these are all the polynomial functions. So if your fx is a polynomial function, then to find the particular integral pi equals to 1 upon phi of d f of x. So here f of x is x raised to m. So what we do here, we expand this 1 upon phi of d using the expansions which are obtained by Taylor's or Maclaurin series expansion, right? So what we have to do, we can represent this 1 upon phi of d in the form of either 1 upon 1 plus p or 1 upon 1 minus p. One of the form you will get, and then we expand this 1 upon 1 plus p क्या होता है? The expansion is 1 minus p plus p square minus p cube plus and so on, and here the expansion is 1 plus p square plus p cube plus and so on. ठीक है? Now the question is, for example, if you are not able to uh, get exactly what want to tell you, see here, if we want to find the particular integral for this differential equation, solve, say, d square plus 3d plus, or say simply d square plus 1, suppose d square plus 2 times y is equal to, say, x square. ठीक है? So to find the particular integral, pi equals to, pi will be what? 1 upon phi of d. So what is phi of d here? D square plus 2, that is operated on x square. So but to expand this 1 upon phi of d, is it uh, out of these two form? Is it one of the two form? No, isn't it? So to get one of the form, what we have to do? We have to take, or we have to get 1 in the denominator. So to get 1, what we can do here? We can take 2 outside, 2 common from the denominator. So by taking 2, what we get here? 1 plus d square by 2. That is operated on x square. Is it clear? Is this step clear? Hello? I want to get one denominator of the form 1 plus p or 1 minus p. So to get 1, I have taken 2 common. And now this is of the form 1 upon 1 plus p, where what is p? P is d square by 2. So then I can expand this. So 1 by 2 times x. What is the expansion? 1. What is the expansion of 1 upon 1 plus p? 1 minus p. What is p here? D square by 2. Plus p square, that is d square by 2 the whole square. Minus p cube. D square by 2 cube. Plus and so on. And that is operated on x square. Okay? So what we can do? We take this x square inside. So 1 by 2 times 1 into x square minus 1 by 2 into d square of x square. Right? This operated on d square, x square, plus d square square is, and 1 by 2 ka square is 1 by 4. D square is d raised to 4 of x square, minus and so on. Now, what is d square of x square? D square means this. See, d of x square is 2x. D square of x square is 2. What is d cube of x square? 0. What is d raised to x, d raised to 4 of x square? 0. So further all derivatives will be 0. Hmm? So we neglect all those further term. So the final particular integral will be 1 by 2 into x square minus half, and d square of x square is 2. So that is half into x square minus 1. Is this clear? This is your particular integral. Everyone please do reply. ये केस क्लियर है सबको? Everyone reply in chat box. Is the case clear? ठीक है. Now the point is, if 1 is not there in the denominator, then we can take either constant term common or the lower degree term common. अगर आपके पास ऐसा है phi of d, that is 1 upon d square plus d, then how do we get d square common? So how do we get 1 in the denominator? By taking lower degree term common. So by taking d common, we will be getting 1 upon 1 plus d square by d, that is d x cube, right? So we expand this using the formula above, that we operate each term onto x cube, and then whatever the expression we get, we operate 1 upon d onto that. What is 1 upon d? 1 upon d means क्या होता है? 1 upon d means, yes, d means क्या होता है? D means derivative. So what is 1 upon d? 1 upon d means integration. We have seen the reason why 1 upon d is integration. Hello, is this clear? तो यहाँ से आपको expansion मिल जाएगा, and up to what term you will expand this? Up to the degree of polynomial. Degree of polynomial कितने यहाँ? 3. So we will consider the terms up to d cube, because d raised to 4 and further all derivatives are becoming 0. ठीक है? So this is how uh, the case is. Now the next is case number 5. Case number 5 is when, am I audible? Hello?
Yes, sir.
Because actually there is some technical problem maybe. So when fx is e to the power ax into v, isn't it? We have seen in the last lecture that when fx is, see here, we have discussed all these three cases. First is e raised to ax, then sine, then hyperbolic, and then x raised to m we have discussed. Now we are discussing the case number 5, e raised to ax into v. So here the formula for the particular integral for this case is pi equals to 1 upon phi of d, that is operated on f of x. So which here f of x is f of x is e to the power ax into v. Now what is this v? This v is a function of x above. जो ऊपर सब फंक्शन देखे हमने, लाइक साइन और हाइपरबोलिक और पॉलिनोमियल फंक्शन, वन ऑफ द फंक्शन विल बी v. ठीक है, तो इनमें से कोई भी होगा, then we can proceed with this case. So what this case is, let me tell you the formula directly. The formula is, we take this exponential function outside the operator into 1 upon sorry 1 upon phi of, there will be a change in this d. D will be replaced by d plus a, where what is this a? A is the coefficient of x in exponential function, and that is operated on v. This is what the logic behind this, or this is the formula. If you want to see how and why we are doing this, we do the same thing we have done in the last exponential and sine. We start with the taking derivatives of e raised to ax into v, and by product rule we go on taking further derivatives using the product rule, then nth derivative, and then from that we will get the required formula, required logic. Okay, so here the main thing is, we write the exponential function outside the operator, and immediately we replace this d by d plus a. For example, pi equals to 1 upon say simply take d square uh, instead of this, let's write like this: d plus 2 the whole square e to the power 3x into say x square. Okay. So what the case says, we take exponential function outside the operator, so e raised to 3x, and immediately we replace this d by d plus a. What is a here? A is 2, है ना, e raised to ax. So we replace d by d plus 3. A is 3. D plus 3 plus 2 the whole square cube. ठीक है, sorry, it's cube, it's a square. So that is e raised to 3x into 1 upon ये क्या होगा, d plus 5 square, that is operated on x square. So as this is a polynomial function, we need to expand this 1 upon 5 of d. But to get for the expansion, we want this 1 upon 5 of d of the form 1 upon 1 plus p or 1 upon 1 minus p. So what we do? We first of all expand the denominator, a raised to 3x into 1 upon d square plus 10d plus 25, right? X square. And then to get 1 in the denominator, what we do? We take 25 common from the denominator. So that will be e raised to x upon 25. Inside it will be 1 upon 1 plus d square plus 10d upon 25. Is it clear? Is this clear to everyone? X square.
Yes, sir.
So this will be your p, and then we use the expansion of 1 upon 1 plus p. Okay. So we will discuss examples onto this. But first of all, let us discuss all the cases, and then we will discuss the combined examples. Now the case 6 is when fx is x into v, where v is a function above. If you have any doubt, you can ask. Okay, related to this, because I'm unable to see the chat box when I switch to this window. So either you drop a message in chat box, or you can unmute yourself if you have any doubt. So this case is particular integral is 1 upon phi of d f of x, where what is f of x here? F of x is x into v. So we do write f of x there. So 1 upon phi of d into xv, where v is any function above, function of x in fact. Okay. So the formula is that can be written as x minus phi dash of d upon phi of d, and this the whole operated on 1 upon phi of d into v. ठीक है? This is the formula, and if you want to see the logic behind this formula, you do the same thing. You start with taking derivatives of xv by product rule, that is x dv plus v into derivative of x, that is 1. So v, right? Then d square of xv, d square d raised to n of xv. So you'll be getting some function of d operated on xv will be equals to x times some function of d, like this. Suppose you'll be getting function of d operated on xv is equal to x into some function of d into v plus that derivative of function of d into derivative of x, which is 1, into v. ठीक है. So by taking this phi of d, अगर इसको हम कुछ अलग नोट करते हैं, डिनोट करते हैं, then we will be getting, suppose इसको हम v बोलते हैं, v1 suppose. So x into v1 plus phi dash of d into v. ठीक है. तो ये जो v है, we are putting phi of d into v is equal to v1, right? तो v का वैल्यू क्या हो जाएगा? 1 upon phi of d, right? So I can substitute here that x v1 plus phi dash of d, and here it will be 1 upon phi of d v1, isn't it? Phi, is it clear? यहाँ मैंने v का वैल्यू यहाँ से सब्स्टिट्यूट कर दिया, v का वैल्यू. So अभी लेफ्ट हैंड साइड में है मेरा phi of d इंटू एक्स इंटू वी. तो v का वैल्यू यहाँ भी मैं डाल सकता हूँ, phi of d इंटू एक्स इंटू वी. v कितना है? 1 अपॉन phi of d इंटू v1. ठीक है. So what we can do? We operate 1 upon phi of d on both sides. What we get then? 1 upon phi of d. तो यहाँ phi of d कैंसिल हो जाएगा. We will get to x into 1 upon phi of d into v1 is equal to इसके ऊपर 1 upon phi of d ऑपरेट करूंगा 1 upon phi of d into phi dash of d 1 upon phi of d into v1. तो and we adjust some terms on both sides, we will get. So what we get here, 1 upon phi of d x into, by adjusting the terms from this expression, we will get 1 upon phi of d operated on x into v1 is equal to x minus 1 upon phi of d, phi dash of d, this the whole times 1 upon phi of d operated on v1. But what is v1? v1 is the function of x. Hence we have the formula that instead of writing v1 we write v. So 1 upon phi of d operated on xv is x minus phi dash, or simply 1 upon phi of d phi dash of d, and that is operated on 1 upon phi of d v. So this is what the proof of the formula. ठीक है. But the proof is not important. You just need to remember the thing, what exactly we are doing while operating 1 upon phi of d over xv will be equals to x minus phi dash, that is derivative of phi upon phi of d, and that is operated on 1 upon phi of dv. ठीक है. And the last case is case number 7. It says when your f of x is x raised to m, or before discussion on this case, let us have some, why, what is the need of this case? Actually we have some remarks from the previous case. If those remarks not get satisfied, we need the next case. So the remark for this case, okay, even fx is equal to x into v. So the first remark is the power of x must be 1. I'm writing here the rule xv is applied only if first power of x is 1, second is 1 upon phi of d. ये जो लास्ट है 1 upon phi of d, this should not be the case of failure. 1 upon phi of d into v should not be the case of failure. मतलब it should not be the case of failure means what? That phi of d must be non-zero. ठीक है, अगर वो जीरो होता है तो वो केस फेल होता है. वन मोर, इफ पावर ऑफ x इज 1 है लेकिन दिस इज द केस ऑफ फेलियर, देन वी कैनॉट अप्लाई दिस केस. सो वी नीड द नेक्स्ट केस. ठीक है, so I'm writing here if power of x is 1 and 1 upon phi of d into v is a case of failure, then we do not apply this case. ये केस हम अप्लाई नहीं कर सकते. सो इन दैट केस वी यूज द नेक्स्ट केस. ठीक है, फॉर एग्जाम्पल 1 upon say d square plus 1 that is operated on x sin x. So you can see here this is of the form x into v, isn't it, where v is sin x. So if I apply the formula here directly, what it will be? X minus phi dash. What is phi dash? 2d upon phi of d, d square plus 1, and that is operated on 1 upon phi of d into v, which is sin x. But if you look at this, when I replace, because here f of x is sin x, so 1 upon phi of d square sin x के लिए क्या करते हैं हम? We are replacing d square by minus a square. If you remember, we have discussed in the last lecture. In case of sin or cos, we are replacing d square by minus a square. Yes or no? So when I replace, that will be a case of failure. तो इस केस में we cannot proceed with this case. We have the next case. Clear to everyone? Clear to everyone? Everyone please do reply in chat box. सबको clear है? All right, so therefore we need the next case. Case number 7. It says when f of x is of the form x raised to m, जहां x का पावर कुछ भी हो सकता है, either 1 or more than 1, x raised to m sin ax, है ना, और x raised to m cos ax. अगर इन दोनों में से कोई भी होगा तो उस केस में हम केस नंबर 7 यूज करेंगे. So let us discuss the form of particular integral for this particular case. pi equals to 1 upon phi of d. हमारा फॉर्मूला होता है 1 upon phi of d into f of x. If f of x is suppose sin x, sorry, suppose इट इज x रेज टू m साइन ए एक्स और साइन ए एक्स प्लस बी वट एवर। ठीक है, तो इसके लिए कैसे करेंगे हम? तो उसके लिए थोड़ा सा हम पीछे जाएंगे, पीछे मतलब कॉम्प्लेक्स में जाएंगे, द बेसिक्स ऑफ कॉम्प्लेक्स, that complex number is of this form z is equal to a plus ib or x plus iy, if you know x plus iy, this is the Cartesian form। उसका और एक फॉर्म होता है that is polar form, है ना? क्या होता है पोलर फॉर्म? r cos थीटा प्लस i sin थीटा, यस और नो? तो cos थीटा को ऑयलर से मैं कैसे लिख सकता हूं? r e टू द पावर i थीटा, राइट? इसको मैं एक्सपोनेंशियल में लिख सकता हूं बाय ऑयलर्स फॉर्मूला, इजंट इट? तो इसका मतलब क्या है कि e to the power I theta by Euler formula can be written as cos theta plus I sin theta। तो मुझे बताओ कोई तो कि what is cos theta for this particular complex number? This is a complex number, उसके लिए this is of the form a plus ib, yes or no? Which is of the form a plus ib। तो a होता है real part and b होता है imaginary part। So what is cos theta for this particular complex number? Cos theta is, huh? It is real part, na? Real part of cos theta plus I sin theta, that is real part of e to the power I theta, yes or no? हेलो, सो गए क्या सब लोग? हेलो, सब लोग हैं ना लाइन पे? ठीक है, इन सिमिलर मैनर साइन थीटा क्या है? साइन थीटा इज इमेजिनरी पार्ट ऑफ e टू द पावर I थीटा। तो हम क्या करेंगे? इंस्टेड ऑफ थीटा लेट अस टेक ax, है ना? तो क्या होगा? लेट मी ऐड द पेज। तो मैं यहां लिखता हूं cos ax, क्या होगा बताओ? cos ax will be a real part of e to the power I ax, and sin ax will be imaginary part of e to the power I ax। अगर मैं इस cos को किसी फंक्शन से मल्टीप्लाई करता हूं तो उस फंक्शन से रियल पार्ट में कुछ चेंज होगा? विल देयर बी एनी चेंज? ऑफ कोर्स यस, है ना? अगर मैं इसको मैं x रेज टू m से मल्टीप्लाई करता हूं, जस्ट लाइक आई एम मल्टीप्लाइंग हियर, हियर x रेज टू m, तो x रेज टू m एंड यहां भी x रेज टू m विल गेट मल्टीप्लाई। ठीक है, तो x रेज टू m cos थीटा इज नथिंग बट व्हाट? रियल पार्ट ऑफ दिस, and x raised to m sin theta will be a imaginary part of this, so that is what I'm writing here. X raised to m cos theta is the real part of uh, x raised to m e to the power ix, and x raised to m sin theta is imaginary part of x raised to m e to the power ix। यहां तक क्लियर है सबको? एवरीवन प्लीज डू रिप्लाई इन चैट बॉक्स। यहां तक क्लियर है सबको? लेट मी नो इज दिस क्लियर अप टू दिस? ठीक है, तो अभी हम फॉर्मूला लिखेंगे पर्टिकुलर इंटीग्रल का। देयरफॉर पी आई, जैसे कि आप देख सकते हो यहां हमने स्टार्ट किया था विथ एक्स रेज टू एम साइन ए एक्स, सो पी आई इज इक्वल टू 1/5 ऑफ डी एक्स रेज टू एम साइन ए एक्स will be equals to, now this is imaginary part किसका, e raised to I a x का, ठीक है। तो एज दिस इज इमेजिनरी पार्ट, अगर मैं उसमें ऑपरेटर ऐड करूंगा तो उससे कुछ फर्क नहीं पड़ेगा। तो लेट मी राइट हियर फर्स्ट ऑफ ऑल 1/5 ऑफ डी इमेजिनरी पार्ट ऑफ x रेज टू m e टू द पावर i a x। तो इसका इमेजिनरी पार्ट लेके फिर उसके ऊपर 1/5 ऑफ डी ऑपरेट करना, और बाय टेकिंग इमेजिनरी पार्ट आउटसाइड एंड बाय टेकिंग 1/5 of d inside operator out inside will be the same, yes or no? पहले इमेजिनरी पार्ट लेके देन 1/5 of d ऑपरेट करना, एंड पहले 1/5 of d ऑपरेट करके फिर इमेजिनरी पार्ट लेना, वन एंड द सेम। कैन वी डू लाइक दिस? हेलो, सो दिस इज द फॉर्मूला, ये है फॉर्मूला। तो आपको ऐसे लिखना है, एंड देन वी विल प्रोसीड विद द केस e raised to ax into v, है ना। we go on solving this, finally we will get the simplification of this form a plus ib and its imaginary part. So what is imaginary part of a plus ib? That will be simply b. So b will be your answer as we are saying imaginary part. अगर वहां cos होता तो हम क्या कंसिडर करते? a. And why will it be of this form x raised to m e raised to ix? इस फॉर्म में क्यों होगा? Because that itself is a complex number, e raised to ix na. So when we go on simplifying it, we will get by separating real and imaginary parts of this complex number, we will get of this form a plus ib, and its imaginary part will be our required particular integral. ये थोड़ा सा केस लेंदी है, लेकिन अगर क्वेश्चन आता है इसके ऊपर तो सॉल्व करना पड़ेगा, ठीक है। क्लियर टू एवरीवन? So I'm writing the formula for cos. Everyone please do reply in chat box. Is this clear? So the formula for cos is pi equal to 1/5 of d x raised to m cos ax will be equals to real part of 1/5 of d x raised to m e to the power I a x, ठीक है। इज दिस क्लियर? सबको क्लियर है ये? Everyone, you can reply in chat box also. Is this clear? ठीक है। So these are all the 7 cases for the shortcut to find the particular integral. So let us discuss the combined examples on these cases. Examples. So let us start with the question. Solve. Let's take example on each case. Solve. The first question is, I think we have discussed the examples of first case, right? First का example हमने discuss किए हैं exponential के. Let us discuss from the second case. So solve d square plus 2d plus 1 times y equal to 4 sin 2x. ठीक है, शायद हमने डिस्कस नहीं किया है ना इसको। लेट मी चेक इट आउट, क्योंकि आप लोग तो बोलोगे नहीं। नो, ठीक है। तो लेट स्टार्ट विद द सॉल्यूशन। इसका सॉल्यूशन क्या होता है? सी एफ प्लस पी आई। तो पहले इसका सी एफ फाइंड आउट करते हैं। टू फाइंड सी एफ. कोई बताएगा जल्दी क्या होगा सी एफ? इट्स रूट्स आर d equal to -1, right? Repeated twice. Because this is the expansion. When I consider the auxiliary equation, that is d square plus 2d plus 1 equal to 0. This is the expansion of d plus 1 the whole square. So when I equate it to 0, I'll get d equal to -1 repeated twice. And for these repeated roots, which are real, we write the complementary function cf is equal to c1x plus c2 times e to the power minus x. Right? To find particular integral pi, we write the formula first. pi क्या होता है? pi is 1 upon phi of d f of x. So let us write phi of d. What is phi of d here? Phi of d is d square plus 2d plus 1 and f of x is 4 sine 2x. ठीक है. So we take 4 outside because that is constant. Constant को हम इंटीग्रेशन के बाहर लेते हैं, तो as this is 1 upon phi of d is integrating operator, I can write outside 1 upon. हाँ, लेकिन फंक्शन को आप बाहर नहीं ले सकते. अगर बाहर लेना है तो फंक्शन में चेंज होगा. ठीक है. So 4 outside and d square plus 2d plus 1, that is operated on sine 2x. तो this is a case of sine. तो साइन ए एक्स प्लस बी और साइन ए एक्स के लिए क्या करते हैं हम? वी व्हाट वी आर डूइंग? वी रिप्लेस डी स्क्वायर बाय
minus a square.
a square. What is a there? 2. So that will be -2 square. ठीक है. So pi होगा 4 into 1 upon -2 square, that is -4 plus 2d plus 1, that is operated on sine 2x. See, I am replacing only d square, not d. So that will be equals to 4 into 1 upon क्या होगा इसका? 2d minus 3 operated on sine 2x. Now still one more d is there in the denominator. So again, to use the case of sine, we need d square in the denominator. And to get d square, what we do then? We rationalize the denominator, right? So when I rationalize means when I multiply and divide this 2d minus 1 upon 2d minus 1 by its conjugate, that is 2d plus sorry, this is 3 na, 2d plus 3 upon 2d plus 3 sine 2x. So that is equal to 4 into क्या होगा ये? 2d plus 3 upon a minus b into a plus b क्या होगा? a square, that is 4d square minus 9, isn't it? A square minus b square. I hope this step is clear. That is operated on sine 2x. Now we have d square for the replacement. So we replace d square by minus 4. So what we will get here? 2d plus 3 upon 4 into minus 4 minus 9 operated on sine 2x. So that is equal to 4 into 2d minus plus 3 upon ये कितना होगा? -25 ना, -16 minus 9 -25. So -4 by 25 I'm writing here, and this 1 upon 2d plus 3 we operate onto sine 2x. So -4 by 25 into 2d sine 2x plus 3 sine 2x. What is d of sine 2x? D means derivative, isn't it? So -4 by 25 क्या होगा? 4 cos 2x ना, plus 3 sin 2x. You can observe here d is completely eliminated, and this is our particular integral. Is this clear? सबको clear है? Therefore we write the complete solution. Therefore y equal to cf plus pi, that is c1x plus c2 e raised to minus x plus pi, that is -4 by 25 4 cos 2x प्लस 3 साइन 2x। ठीक है, इज दिस क्लियर? सबको क्लियर है? एवरीवन प्लीज ड्रॉप योर रिप्लाई इन चैट बॉक्स। यू कैन आस्क योर डाउट्स इफ एनी। देख लो एक बार कंप्लीट सॉल्यूशन। इज द पॉइंट क्लियर टू एवरीवन? सबको क्लियर है? एनी डाउट?